A scientific study was published last month that should have been front-page news everywhere. It was not. And the implications are far more unsettling than most people realize. For the first time in a controlled peer-reviewed study, modern AI systems passed the Turing Test, not by gaming the rules, not by tricking the evaluators, by being genuinely indistinguishable from humans. The Turing Test, proposed by Alan Turing in 1950, is simple in concept. If a machine can engage in conversation so naturally that a human judge cannot reliably tell it apart from another human, the machine has demonstrated human-like intelligence. For 75 years, passing this test was the holy grail of artificial intelligence. And now it has happened. But what does it actually mean? That is what we are going to explore today. Let me be precise about what the study actually found. Researchers at UC San Diego conducted a randomized controlled experiment with 500 participants. Each participant had a 5-minute text conversation with either another human or one of 3 AI systems. GPT-4, Claude, or Eliza, the 1960s chatbot that uses simple pattern matching. After the conversation, the participants had to guess whether they were talking to a human or an AI. The results were striking. When talking to Eliza, the 1960s chatbot, participants correctly identified it as AI only 22% of the time. Even a 50-year-old system fooled most people. GPT-4 was identified as human 54% of the time. Think about that. People were more likely to think GPT-4 was human than to correctly identify it as AI. Claude performed similarly. And here is the kicker. When participants talked to actual humans, they correctly identified them only 67% of the time. The gap between human and AI identification rates was within the statistical margin of error. In practical terms, modern AI is now as convincing as humans in text conversation. But before you conclude that AI has achieved human-like intelligence, we need to understand what the Turing test actually measures and what it does not. Alan Turing himself knew the test was imperfect. He called it the imitation game, not the intelligence test. His point was philosophical, not scientific. The question, as Turing framed it, was not can machines think. That question, he argued, was meaningless. The better question was can machines do what we as thinking entities can do? Passing the Turing test proves that AI can imitate human conversation. It does not prove consciousness, self-awareness, understanding, or genuine intelligence. A parrot can imitate human speech. A calculator can perform mathematical operations faster than any human. Neither is intelligent in the way humans are intelligent. So why does this matter? It matters because human society is built on the assumption that when you interact with another entity, you know what that entity is. When you call customer service, you assume you are talking to a human unless you are told otherwise. When you read a product review, you assume it was written by someone who used the product. When you interact with someone on social media, you assume there is a real person behind the profile. These assumptions are the foundation of trust in the digital world, and every single one of those assumptions is now demonstrably false. AI can impersonate a customer service agent. It can write product reviews. It can maintain a social media persona. We are entering an era where trust cannot be based on the content of communication alone. You can no longer trust something just because it sounds human. This has profound implications for everything from online dating to political discourse to financial transactions. When you cannot tell who is real, how do you decide who to trust? The researchers who conducted the study noted something fascinating. The human judges were looking for signs of artificiality in the wrong places. They expected AI to make factual errors, to be too formal, to lack emotional depth. But modern AI does not make these mistakes. It can be casual, emotional, and factually accurate, at least on the surface. Instead, the real tells were subtle. AI tended to be too agreeable. It rarely pushed back or disagreed. It did not share personal anecdotes that felt lived in and specific. Human conversation is messy. It has tangents, interruptions, contradictions, emotional shifts, and references to a physical body and a lived life. AI mimics the structure without the substance. But here is the thing. As AI improves, even these subtle tells will disappear. The next generation of models will be trained on more conversational data and will learn to mimic human messiness. Some researchers argue that the Turing test was never a good test of machine intelligence. They point to what is called the AI effect, where every time AI achieves something, we move the goalposts. Chess was considered a test of intelligence until AI mastered it. Then we said chess was just calculation. Go was the real test. Then AI mastered Go, and we said that was just pattern recognition. The same thing is happening with the Turing test. Now that AI has passed it, we are saying the test was flawed all along. But maybe we should stop moving the goalposts and start asking harder questions. If AI can do everything humans can do, one task at a time, at what point do we admit it is intelligent? There is a deeper philosophical question here that goes back to what philosophers call the hard problem of consciousness. We do not understand how human consciousness works. We cannot explain why a particular arrangement of neurons in a brain produces subjective experience. We do not know if consciousness is binary, a spectrum, or an illusion. So when we ask whether AI is conscious, we are asking a question that we cannot even answer for ourselves. We do not know what consciousness is. How can we test for it? Some AI researchers believe that consciousness is an emergent property of complex information processing. By that definition, sufficiently advanced AI would be conscious by default. Others believe consciousness requires a biological substrate, something that silicon cannot replicate. Without biology, no matter how sophisticated the processing, there is nobody home. We simply do not know which view is correct, and we may not know for a very long time. Probably not until it is too late to matter. Here is the practical reality. Whether or not AI is truly intelligent or truly conscious, it does not matter for most of the ways it will affect your life. An AI that can perfectly imitate a human can scam you, manipulate you, radicalize you, or defraud you, whether or not there is conscious experience behind its words. The threat is not that AI will become conscious and decide to harm us. The threat is that AI will become indistinguishable from humans, and bad actors will use it to harm us. We are already seeing this. AI-generated voices are being used to impersonate family members in emergency scams. AI-generated faces are being used to create entirely fake identities. AI-generated content is flooding social media with information that looks legitimate but is completely fabricated, and we are still in the early days. What happens when AI can maintain a months-long relationship with you, building trust before exploiting it? What happens when political campaigns deploy millions of AI agents that have personalized conversations with every voter? What happens when you can no longer trust any digital interaction to be with a real human? This is not science fiction. This is the world we are building right now. The solution is not to stop AI development. That genie is out of the bottle and it is not going back in. The solution is authentication. We need cryptographic proof of humanity. Systems that allow you to verify that the entity you are interacting with is a real person, without revealing their identity or compromising their privacy. Some proposals already exist. WorldCoin, despite its controversies, is attempting to build a proof of personhood system. Governments are exploring digital identity frameworks, but none of these solutions are ready for the scale of the problem. We need a global, privacy-preserving, decentralized identity verification system, and we need it yesterday. Passing the Turing test is a milestone, But it is not the milestone most people think it is. It is not proof that AI has become human-like. It is proof that our definition of human-like was never very good. The real test was never whether AI could imitate humans. The real test is whether we, as a society, can adapt to a world where imitation is indistinguishable from reality. And on that test, we are failing. We are not ready, but we still have time to prepare. The question is whether we will use it. That is the deep dive for this week. Subscribe and hit the bell so you never miss an episode. We go deeper than anyone else on the stories that actually matter. In the comments, I want to hear from you. Have you ever been unsure whether you were talking to an AI or a human? What happened? Share your story. Thanks for watching. Stay curious, stay skeptical, and I will see you in the next one.